Welcome, everyone. Thanks for coming to our Western Holiday Edition. There's nothing going to be a holiday about this edition. I think we've got a pretty exciting lineup. I'm going to, as always, talk about some of announcements in the world of Angular at the beginning here. Then Josh from a startup in Berkeley is going to come show us integration with Three.js and Angular. I'm pretty excited about that. And at the end, Mishko is going to talk a bit about the future of JavaScript with a presentation on where we are on Atscript. All right, if we could switch to slides, please. Just maybe a couple other announcements. One is, when you ask questions here, like always, we're going to make you sign a piece of paper that says it was okay that my comments got broadcasted on the live stream. So think before you ask, and make sure you're okay with having your comments broadcasted. And I think we've got t-shirts for you if you ask good questions. Not pandering questions, those get no t-shirts. All right, announcements. So honestly, we were a little bit burnt out from our work up to 1.3 and Angular 2 and NG Europe, but we've actually come back kind of strong. And we had several releases in the we had 1 release in 1.2 and 3 releases in the 1.3 branch. Most of it was bug fixes. There was a couple features, but we're now in the planning phases for an Angular 1.4. We're gonna publicly release a first cut of this based on what we know from talking to all of you, and we'll give you space to comment on it so you can give us input on what we should be including. We've made a lot of progress on Angular 2. We've gotten many of the core components completed. We have the template compiler, change detection, dependency injection, expressions, and a bunch of other pieces working together. And we've been able to actually string them into one piece and put together a Hello World example. And I've linked it from the slides. You can go check it out. We're also driving Angular 2 based on benchmarks because we want it to be significantly faster than Angular 1 and give you some reason to go through the upgrade path. And so we've started with a tree benchmark. We'll move soon to a tables benchmark, but we'll be showing you how this compares to Angular 1.3 and how much faster it could be in Angular 2. The next things we're going to work on, like I said, the more benchmarks. We're going to be working on zones, and if anything you take away from zones, it's that you no longer have to call scope.apply. So we're going to try to make the world nicer in that way. We'll be working on that soon, and then building the first directives in Angular. There's a couple other projects I should mention. One is we've kicked off a IET&N project to make localization and initialization easier. There's a link there with a bunch of notes, the design sketch, and some videos from meetings that we've had if you're interested in this. The plan is that we're going to deliver it both in the Angular 1.x branch and for Angular 2. But for Angular 2, we think we can do a much better job at this by including some of the bits around pluralization and gender into the core template syntax. More details on that coming, but also a very good thing for companies who want to deliver globally. You've probably heard about the new router we're developing, and this is going to be available in both 1.x and 2. We've released a progress tracking doc so you can see how it's coming along, and there's a link there. There's a demo that you can look at that instead of PhoneCat, which is our core tutorial, Brian called it Phone Kitten. Yeah, it's very clever. And one of the things he's working on next is making sure that the transitions work very well with animations on mobile use cases. Last big thing on the material design project, which is our UI plus layout plus all of the components you need to build rich interfaces. We've made a couple improvements for the 1.6.1 release. We've got a much simpler layout engine for you to use now. It's now themable. You can add colors of your choice. There's good documentation on that. And it's now available on Google CDN for fast deployments. Just one last little bit, nothing really to announce, but we had a nice little visit from the TypeScript folks at Microsoft. They came down and gave a presentation. You might want to watch this. This is related to what Mishko is going to talk about in Atscript. We would love it if all of us who care about types in JavaScript could get together under one standard. We'll be talking about this more, but if you want to see how good we think the editing experience could be, maybe check out this TypeScript video that Anders from the Microsoft team came down and gave us a demo about it. All right, that's it. Here's the link to the slide deck. We can find all the other links. I'll invite Josh up, and we'll hear about using Three.js with Angular. Thanks.
All right. Hello, everybody. So today we're going to talk a little bit about integrating the Three.js library with Angular. I've been working for the last few years trying to figure this out, and I thought I'd give a couple patterns back to the community. So first off, here's my info. The code's already up on GitHub if you want to check it out. I have a Twitter account, but I mean, does anybody really use Twitter anymore? Anyway. I also have a blog, blog.tempted.com. So who am I? I'm a software engineer. I work for a startup in Berkeley. Right now, we're still kind of stealth mode, but we have a private beta going. Essentially, we're making a WebGL-based app that allows you to explore music visually. It's really, really cool. Anybody who likes music is going to like this app. That being said, it's a private beta, so if you use the NG hashtag or NG meetup hashtag that I have listed on the top there, I'll try and get you guys an invite. It's a very fun app. So today, what are we going to talk about? Well, a couple patterns. The first one is how to integrate Angular and Three.js to make a model viewer. Secondly, we're going to do the same thing again, just a different way, right? And lastly, we're going to talk about grunt and compilation and closure compiler compilation approaches for both of these. Closure compiler, in case you guys don't know, is a compiler that's a Google project, and it's used very heavily. It does essentially type checking amongst many, many other wonderful things when you're actually compiling your code for production purposes. So, why? Well, these patterns I've sort of developed, they're pretty great. It's very high productivity, low barrier of entry. All the code's up there. It's commented well. Take a look at it, and you can very easily turn from being just a regular web dev into a 3D web dev. With projects like DIY VR, the Oculus Rift, WebVR coming out, there is really no gap anymore between developing 3D web applications and developing web applications. Also with this pattern, I wanted to demonstrate a way to isolate Three.js code from Angular UI and UX code, right? So you can think of Angular as this beautiful framework that sort of surrounds this chaotic hub of Three.js, right? It's just a web and, it's crazy. But so part of these patterns is isolating that logic. So this is an Angular meetup, so some of you might not know what a Three.js library is. Essentially, it's this incredible JavaScript library that's been out there for about 4 years. It's got hundreds of people working on it, thousands of commits, I think around 10,000 now, and it's absolutely great. The majority of the 3D work you see out on the web is either Three.js or leans heavily on Three.js. There are a couple other libraries out there as well. There's Babylon, some newer ones, and if you notice, if you go to the examples page, you can see some incredible code implementations. So Angular who? That, of course, is us. Like, we're all here because of this little graph right here. This is from Google Trends for this last year. Angular is just taken off. And if we're coding in Angular, as most of us are, you can tell why. It's highly productive. It just works. It sort of fits with how my brain thinks. So let's actually demonstrate this guy. So this is a Three.js model viewer written in Angular. You sort of see you can rotate around, zoom in and out. I have these little controls on the left side called toolbar. You sort of see as I manipulate the input range slider, it'll actually manipulate the guy there as well. Yeah, inside these little tabs on the bottom right too to sort of open and close stuff. This also leverages a local storage module. So whenever I actually copy a URL for, say, a JSON URL for a JSON model, or an OBJ and MTL or a GLTF model, it'll actually load those models directly into the scene and then store them in local storage. So we'll try a sample GLTF model. So then I have this little CyberDuck here, right? If I refresh the page, there's my little GLTF duck right there. You can do a bunch of different kinds of models. Here's a no texture model, it's just an OBJ. These are all 3D model formats. So what I'm actually demonstrating, though, is a way to sort of interact and sort of encapsulate a 3D scene sort of with the whole Angular layer around it. It's pretty straightforward. All this code's up again, so take a gander at it. So back to the slides. So how do I actually build it? So let's start off with the UI layer with the elements and controllers. There are two primary controllers. There's the app controller, which is sort of the parent app for the entire application. It sort of controls the window visibility, it controls the viewer factory initialization, and everything else. So there's actually 4 HTML files. For these includes, I use a directive include, and at the very beginning of the boot, the app initialization, it checks to see if you're actually using Chrome, and it'll forward you the Chrome HTML, sort of set that in your view. Subsequently, it'll load all these other directive includes, including the file loader, which is sort of front and center. Notice that the directive include for the file loader correlates to the file loader controller. So I only use 2 controllers, but there's so much logic in the file loader controller, I decided to sort of associate that logic with the file loader. Great. So let's talk about dependency injection across Angular components. So in the left middle side there, you can see my factory for the viewer. This is the factory that sort of creates the entire 3D scenes, and this is sort of what you have to manipulate and work with to sort of manipulate the scene. Right? Notice that it's injected into 3 components. There's a directive for select, and there are also the app controller and the file loader controller. The app controller in this case will essentially manipulate the translate, scale, and sort of rotation transformations, and sort of push those into the factory. Notice also there's only one Angular component injected into the factory. That's the message bus. That's because when something happens in this 3D environment, you need a way to sort of communicate that reaction back out to the UI UX layer. And so in this case, when something happens, say you select something, it'll trigger an object selected event, push it back up to the Angular layer. The message bus will broadcast some root scope, so then subsequently any downstream scoped variables can actually execute upon that select or that initialization. So the viewer factory, this is sort of the meat and potatoes of this entire application. This is where I have I initialized from the app controller. If you notice on the right side are the 3 Angular components that have the viewer factory injected into them. And I have sort of the init, rotate, scale, and translate, and all these other functions. When the app controller initializes, it calls viewerFactory.init. This builds up my 3D environment. This new viewer scene, this is sort of a super class I created that controls everything in the 3D environment. It also builds out the graphics, it sort of sets up the renderer, and subsequently after initialization we launch it to a render loop. In 3D code, essentially the render loops is what animates the 3D animation. It sort of pushes along at 60 frames a second to make everything happen in the 3D environment. Notice also on the bottom I have a translate function with a couple annotations on it. So whenever you manipulate that range slider in the toolbar controller, what it's actually doing is it's calling this viewerFactory.translate function, passing in 3 numbers, and then we're setting the position on the current model. That's sort of how you connect, how you bridge from the actual input sliders into the 3D environment and get a reaction. Let's talk about the viewer factory architecture. So it's a singleton, obviously. We have an init function to sort of start the 3D scene, and we also have an animate function. This is what creates the render loop. Inside the viewer scene, this is where I sort of store all these subclasses that are 3D related. So the 3 scene is essentially just an array where we put all the 3D objects that need to go into the scene. In the render loop, that scene graph is parsed, which sort of creates the movement of fake realism of a 3D environment. There are also a couple other classes in there too. Orbit controls, for example, allows me to move around the scene, zoom in and out, translate, pan up and down. And of course, the viewer setup is just a class I wrote that sort of sets up the scene. It creates the initial grid, it creates the lights, it sort of positions the initial camera, everything else. And the last class on the bottom is the wrangler. That's sort of what I created to deal with wrangling the 3D objects that you're loading into the scene. All right, so use case. So let's say a user clicks on the canvas element. The canvas element has the WebGL layer in it. And then you want to sort of figure out whether or not that's intersected with the actual scene or an object in the scene. So in this case, we have a select element on the canvas, and essentially it takes a tap, which is a hammer feature or a click, and takes those mouse coordinates, converts them to what they call non-device specific coordinates, NDC coordinates, and then passes those coordinates into the make selection function. The make selection function inside the Three.js factory will essentially take those coordinates, project array from where the actual click happens, and then it'll see if it actually intersects with the 3D object in the scene. If there's an intersection, it returns the intersected object and with the object selected, so any components that are listening to it can subsequently react to that intersection. So that's sort of in a nutshell the first pattern for a Three.js environment integrated with Angular. But I have another pattern for you. So does anybody know what the most profitable movie is in Hollywood?
Army of Darkness.
No, close. Which is an awesome movie, by the way. It's actually the sequel, right? So back in the 80s, Hollywood did a lot of research and figured out what is the best movie we can use to maximize the profit for our shareholders. Well, it's a sequel, unfortunately. And if you go to the theaters today, we see that. Even Pixar and Marvel and everybody else, everything's a sequel. So we're going to do the same thing, but we're going to do it a completely different way. It might seem anticlimactic, but really this demonstration is just sort of a demonstration of two technical ways to achieve the same product. So in this sequel, we're going to start controller as controller, and we're also going to introduce annotations. And lastly, we're going to prototype everything. So no more closure pattern with the factory, no more weirdness that you see in Angular documentation on Stack Overflow. It's going to be prototypal pattern across the board. All right, so it's a big reveal. And it's the same thing, right? Great. Yes, excellent. Got the little duck. Everything's happening. Notice I have a V2 up here versus the V1 over here. So it is separate code. Sorry, but that's how it goes. So controller ads, let's talk about it a little bit. Controller ads is a newer feature, I think in 1.2, 1.3, and it introduces a controller level scope. So if you have multiple controllers with the same name, or maybe you have the same scoped variables or scoped functions on different controllers, this sort of removes a possibility that your click or your function click, your data is going to percolate up to the wrong controller and then do something wrong. It's sort of like having two show visible or show window controllers on buttons in Angular world, and then clicking on one and it ends up hiding the wrong or shows the wrong window or has the wrong reaction. So controller ads is very useful. So services. So the factory I had that was a viewer factory is now a viewer service. Notice I have all the same functionality on the prototype now. And of course, one of the advantages of the prototypal pattern is that you're only storing one copy of each function in memory. So if you're going to have 40 viewer factories, that's going to be a lot, like just an absolutely horrible memory hog. So with this new approach, there's no more factories, no more closure patterns. The prototypal service, of course, we're using new to construct, and then we're leveraging this and bind inside of all the methods, prototypal patterns. For me, I love this pattern. It saves memory, of course. It saves me time as far as implementing the pattern, and also searches. Like when I've been dealing with learning Angular over the last 2 years, I spent quite a lot of time on Stack Overflow just trying to figure out what this pattern is trying to do. I find that I have far fewer questions with this newer pattern. And of course, single pattern for everything. All my Three.js code is written in the same kind of pattern, the prototypal pattern. And it is, in my opinion, the best way to code JavaScript. So prototypal Angular. Top left example, we actually see the viewer service being constructed. I use ng-inject to inject these Angular components into the viewer service, in this case timeout and message bus, and then later we call the init function on the actual prototype for the viewer service. The bottom right one, you actually see the old closure style that I used in V1 of this project, and it's a little different, but again, you have all this internal state and you return a bunch of functions on the return object for the factory. So annotations. I mentioned closure compiler earlier. This is, many of us might use Minify or Uglyfy or part of the grunt compiler process. Annotations are pretty great because it allows us to sort of specify the param types whenever we're creating a function. So for example, on the left side, in my constructor here, I'm actually dependency injecting Angular timeout and viewer message bus. Now, if I compile this code with closure and it finds that I'm actually not doing that, it'll throw an error and won't actually let me compile the code. So same way with the translate function on the right. Let's say somewhere in my UI interface, I'm using this translate function, but instead of passing numbers into it, for some reason it's passing strings. And if you pass a string into a position set in Three.js, your object's going to disappear. You've essentially killed the object in the 3D environment. So it's very important when you're compiling your code to make sure that your functions, especially functions related to a 3D environment, are getting the right values into your code. So app initialization is also a big change. With the version 2 approach, I sort of define everything in sort of a root module location. So we're talking about directives, filters, services, controllers. These are all written in a prototypal pattern, again, using ng-inject. In the first version, really the DOM, whenever the templates are compiled, the DOM start, it actually sort of loads all the controllers. Now we can sort of specify all this stuff outside of the old style, and it just looks cleaner, it makes more sense, and a lot of people really dig it. So finally, compilation. So the first version, the V1 version I have up on GitHub, uses ng-annotate, Uglyfy, and grunt to do this compiling process. Sort of concatenates everything together, pushes them up. It's good. It works. And 90% of websites can use this approach. No problem. Closure compiler, of course, does type checking, which is really important for a production level, especially a 3D kind of application. And it also does several other features too. In this example, I'm only using simple optimization, but there's an advanced optimization too that might work for some websites, but I haven't even figured it out yet. It's crazy. But again, Clojure Compiler does type checking, of course, and also does dependency chaining. So if you have your provide requires set up, it doesn't really matter where you're actually putting files, and you can sort of exclude entire swaths of your application, say debug tools, before you push something to production. All right. So again, let's review. We've got one app. I've got two patterns. The V1 is sort of most common. It's sort of like what you see on the AngularJS.org website. And we have the second pattern too, which is sort of prototypal for everything. And as far as I understand, the second pattern that leverages controller adds is also a bridge to Angular 2.0. So if you're going to look forward and sort of make decisions about what kind of patterns to use, I'd highly urge to use V2. And from a personal standpoint, you know, I'm not a fan of closures, and so this little V2 approach doesn't really use factories, which makes me happy. All right, so if you put all that together, you can build pretty incredible apps. This is a screenshot of our app. Again, napaverth.com. We have a few open positions. There's a mobile developer, backend guru, UI, UX, and QA. And what you're actually looking at is a map of artists. The map sort of demonstrates the positional relationships between different artists, different genres, different years, and it's a lot of features in here. In this case, I'm actually a really big Daft Punk fan, and I'm sort of, you're watching the map, or you're watching the video Around the World by Daft Punk while you're browsing the map. And notice also that the map's hierarchical. You can see smaller little dots right there. That's because those guys aren't as prominent in the map or music relationships to the world. And in this case, I've actually clicked on the disco subway line so that it actually demonstrates all the related artists that relate to disco who are also related to Daft Punk. So again, I urge all of you to check it out. It's just use hashtag NGMeetup and we'll get you an invite. And if you have a mobile developer, backend guru, just really good guys that want to work with an incredible team, an incredible product, please drop us a line. And that's it. So thank you. I think we had another announcement.
So we'll take questions at the end. Mishka will come up now and regale us with how we're doing on Atscript.
All right, so I would like to give you guys a little bit of demo of Atscript, where we are today. First of all, I'm assuming most of you guys heard of it? Yes? Yes? Silence? So let's just make it clear what it is. It's really a code name for what we think of the future of JavaScript will look like. So it is not a different language from JavaScript. It is JavaScript. So you start with today's JavaScript, which is known as ECMAScript 5. And it's pretty clear that ECMAScript 6 is around the corner, right? So we have these polyfills like Tracor. And Tracor allows us to compile ECMAScript 6 code down to ECMAScript 5 code. There's also other technologies out there, like, for example, TypeScript with its types. Technically, TypeScript does not yet have ES6 support, but it's just around the corner, so they're soon going to have that as well. What TypeScript brings to the table is a type system, so that you can assert things about your system, such as that something is of a particular type. Now, let me make something else very clear, which is that types are very polarizing. Some people love them, some people hate them. I think the reality is a little more complicated, but what we want to make sure is that we don't force you either way. If you love them, you can use them. If you hate them, you don't have to. That is completely optional and opt-in. And what's more important about it is that you can freely mix and match systems that have the types and then don't have the types. So here we have, let's do something, very simple. Okay, my hello world's running, so let's just run my IIT. Here's my hello world, and so we could do something fun in here. We can say declare a variable x equals 5, something we could do in JavaScript, right? Nothing really exciting about that. But let's do something that TypeScript allows. And we give it a type. And then when we execute this, we basically say, hey, wait a minute, I was expecting a string, got a 5, right? And the thing about this is that it is runtime type checked. So a TypeScript, what the TypeScript gives you is it gives you a statically checkable system. The Atscript says, well, sometimes you want to do it statically, sometimes you want to do it dynamically. So we would like to support both of these. But there's one more thing that we would like to do, and that is annotations. So by putting all these things together, we're basically saying, if you look far enough in the future, we think that this is a particular path that JavaScript might take, and we're certainly going to try hard and make sure that it does take, that you would have something like ES6, some kind of a type system, which most likely will have the syntax of TypeScript. And also, we think we should have annotations. Now, what exactly are annotations? That's kind of a more complicated beast to kind of explain. So imagine you have a class. Let's say we have a class door. And you want to annotate it with something like material is wood. We have to declare what material is. Oops, no comma. By the way, this is a IntelliJ, and this is actually an early build which actually kind of understands something, because TypeScript and Atscript is very similar. This thing actually understands TypeScript and the annotations as well. So here we could say, well, what is material? Well, material is just a class. Oops. And it's going to have constructor. And it's going to take name, or rather type. And so I'm going to say this type equals type. Okay, so if I run this, it should still work. Rather, it's just going to complain. So let's just take this out. It still runs. But here is the magical part. This is what introspection is all about. So if I ask, what is door.annotations? And I run this, notice at runtime, I can actually see that the annotations of it is wood, because that's what we have annotated with. So let's unroll this a little bit, because there's a lot of new syntax that you see over here, and you might not be familiar with it. So one of the things that ES6 does is it allows us to declare classes. How many people are excited about the fact that classes are now first-class citizens? Yes? At least some of you guys? Come on, show me some excitement. All right, so, but you say, well, what if I don't want to use this? What if I want the good old way of declaring my classes in the old days? And so what I want to show you is you can certainly do that. So the equivalent piece in the good old JavaScript would be var material equals function, which takes, it's going to say this dot type equals type, and it takes type, right? So this thing over here is just a nicer way of saying the above. Now in this particular case, it's actually a couple of lines longer, but in most cases, it's actually become shorter. So if I delete this code, notice it will still work. Ta-da! Isn't that wonderful? I lost the name, so we can actually do the more typical way of doing it, which is like that. That should also work. So notice all that the annotation really is a instantiation of that particular type. So for example, if I didn't want to use Atscript for this particular thing, I could unroll it back, and this just becomes, door.annotations equal to new material and if I still run this, I still have the same result. And obviously, this thing is just function door. Right, that's all you get. So all we are basically creating is just a simpler way of expressing the stuff that you could already express in ECMAScript, but in a syntax that's much, much friendlier. Now, let's see if we can do more stuff with it. So let me undo all this stuff and go back to the nice and pretty format. Okay, let's see, make sure. So we still have material. And now let's do some fun stuff. So for one of the things you could do is you can, for example, specify that you can declare a type ahead of time. So you can say that type is, and I'm going to do something silly. I'm going to say it's a number. Now when I execute this, notice I'm going to get an error that says, hey, you tried to assign into a number, but you're trying to assign essentially a string. So we can do verifications such as these. Of course, let's put them here. Optionally, again, all of these things are optional, right? We can specify the types that we intend to use. The other thing I want you to notice is how the environment, I can just type and run my code. There's no, but there is a translation step, but thanks to something like Karma, it is very transparent and it's very easy to use and natural. It's as if the browser supported this today. And we want to make a big point out of this, that we can easily allow incremental compiles on per file basis, so that even if your project gets very, very large, the experience is still going to be the same exact line. But let's do one more interesting thing we can do with Atscript, and that is if you have material, notice the material takes a string type. And just like we can do introspection, which means we can at runtime look at the content of what we have, we can do something similar at look at the parameters as well. And notice in this case, it's going to be not very helpful because string is a special type. Okay, let's do something more fun. Let's say that the door, in addition to it says let's say the door also takes material. If we execute this, we're actually going to see that the parameter in here is of type material. And what this allows us to do is it basically brings the JavaScript into the same capabilities that people in Java and other languages have already enjoyed for years, which is introspection is an important part. And this allows whole kinds of slew of interesting libraries to be built. So for example, you guys familiar with Express and how you can declare which methods do which operations. You could do something, it would be much nicer if you could just annotate a method and say, oh, this method will hinder a GET request on a following URL. It would be a much nicer way of doing it than the current registration process. So many libraries that you are very familiar with already could be rewritten in a much more declarative way into it. So if you think about what these annotations really are, is that they are declarative nature that we come and love from Angular, not only just for your HTML, but also to some degree for your imperative code in JavaScript. And by giving that together, you are providing almost like a DSL for the developer that they can use to build more interesting things. All right, so this is where we are with Atscript today. Let me show you how something like this can be used. So we're working on Hello World. So before I do that, let me just show you. I execute this. Angular 2 is well alive. Currently, we have about, as you can see, about 476 tests and growing. So what does the Hello World kind of look like in Angular? Angular 2 is based around the concept of components. If you're familiar with web components, you should be familiar with it. This is what a simple component might look like. This one is a little more complicated than it needs to be just because we wanted to show off the capability of dependency injection. But here you're simply saying, hey, here's my app. Top level component is hello CMP. Let me see if I can run it for you. Oh, here it is. This is all it does. It says loading while it's being booted, and then it says world. So how does that work? Let's see. Let's look at the HTML. It works because we declare a component called hello app. And in Shadow DOM, there's this concept called the light DOM, which is what goes inside of it. And then we allow the component to bootstrap itself. How do we know that this is the component? Because each component has this annotation, which I've shown you how we can use and how we can use it in the framework. So now we're simply annotating this particular class, saying, okay, this class, I want the framework to use in a very specific way. And what I'm saying here is that this is a component. So wherever you see this CSS selector, which is hello app, in this case, see if we can get them side by side. In this case, you're saying, if you see hello app, which is right here, apply this particular controller to it, right? This is essentially a controller that you're familiar with from Angular 1x. In here, we're saying we are going to have a particular template. This is what's known as shadow DOM in this world, and here is the template. In this particular case, it's inline, but it doesn't have to be. It can be loaded from a URL or something like that. And we're injecting a greeting service, and we're taking the greeting and assigning it to our greeting variable. So the greeting now becomes available for data binding right here. Double curlies that you're, again, probably familiar with. So what this basically does is that once the component starts up, it locates hello app and prints this particular annotation, which is world with a question mark, with a exclamation point on the end, and that's all we have. So what I wanted to show you is just how something like an annotation can really simplify your expressivity. So before, what you had is this complicated directive definition object. Now you can have directives and be expressed with a simple thing, something like this. It also allows us to use dependency injection because we can retrospect on fields, like you can see over here, because of the type information and so on. Now again, all this stuff is optional. You can use the code in good old ECMAScript 5 way, or you can take advantage of these particular things. Not sure what else can I show you, so I would like to suggestions if you wanted to see a specific area that I can demo.
How will this interact with other web?
So the question is, how will this interact with other implementations like Polymer and Xstack? You know, one of the key points of Angular 2 was that Angular 1x really was created before the Web Component standard, and as such, we couldn't have anticipated that such awesome things as web components came in. With Angular 2, we really wanted to say, okay, what's the latest technology? Where is the world coming to? And make sure we are embracing these technologies. So Angular 2, from the very beginning, embraces things like shadow DOM, web components, and so on. And we had to actually do many changes around the data binding syntax so that we can bind to things like elements that we essentially have no information about. And this is kind of the driving motivation for it. So to make the long story short, we were working very hard so that out of the box, you can just throw in a web component, an Xbox, a Polymer, or what have you, and it'll just work without any additional work. That's the world we're aiming for, and so far we're on track over there. Yes, I know you're excited. We're excited about that too. So what's here once remains to be decided? Really, until we ship 1.0, we're kind of free to change anything we want, which basically tells us that, hey, you know, as long as we have good ideas and there's good justifications for it, we're free to change. Having said that, you know, as you're approaching 1.0, we feel like we're getting more solidified about these things. So at this point, we kind of feel like we really have all the pieces in the right places. There might be surprises, and we're willing to change if surprises come. But we feel pretty confident that we kind of figured out all the main pieces, you know, how to work with web components, how the Atscript should work, what the experience should be for the end developer, how they can unit test everything. You know, everything that you have come to love about Angular, make sure that it's here, but it's better. How will it work with normal JavaScript, or will it be built on? So the question is, how would this work with JS Compiler? So JS Compiler is another project of Google 3. JS Compiler currently only supports ES5. They're working on ES6 support. As of right now, it's not supporting Atscript, but it's something that we're exploring. One of the changes we wanted to do with Angular 2 is to make sure that minification works a lot better. So for example, things like minifying in Angular 1x, the dependency injection is off of the strings, which are the parameter names, which even though it's clever, it has issues when it comes to minifications. Here we're taking on the keys that are actual references to another types. And because it's references to types, the whole issue of namespacing goes away. collisions goes away, minification goes away. So a lot of things have been changed so that minifications would just work a lot better out of the box.
Questions. First, how we are loading the scripts using that dollar scripts that is in the index, and the other one is how is browser support for this Atscript for now.
Okay, so how is this getting loaded? So we have our own internal build system that does this, and this is what the build system looks for. Is it looks for dollar scripts, and the reason for that is because when you transpile ES6 code, you need to select which module you like to use. So Tracer comes, or ES6 is going to have its own module system, which was heavily inspired by the previous AMDs like require.js and so on. But it also knows how to produce code in require.js format and as well as common JS format and so on. And so depending on which format you select, we need to generate a different set of script tags. And this is our placeholder to say, like, when the build system runs, please insert the correct set of script tags in here. So this has nothing to do, you are not going to write your applications this way. This is our own testing harness to kind of get this thing going. So you would have normal script tags in there. The second question was browser support. The whole point of Tracer is that Tracer transpiles everything down to ES5. So the code itself, all the browsers today will be able to run ES5. What comes trickier is what browsers will support other capabilities. Currently, we're aiming for evergreen browsers, and I think that most modern browsers qualify, and I think it's, I want to say 10 or 11, I can't remember what the right magic number there is. And it has to do with some URL support or something like that. It's not a question of whether the code will run, because the code will run. It's a question of whether the browser has the right API for us to express all of these particular things. For now, we're just aiming the evergreen. Later, we'll see how that goes out.
Do you have plans to add source map support?
Oh, source map support are already here. Thank you for asking about source map support. Let's debug this code. This is the most important part, right? Of course, I'm not going to have this set up right, but let's see. Let's give it a try. Let's go to our IIT. Okay. So when you're in your web browser, you can look at either the source or the transpile, and I can never remember which one is which. Let's see. Yes, I got the right one. And so this includes the source map. And so you can go in here and you can, for example, place a breakpoint right here. And you can refresh it, and you will see that we stop at this particular breakpoint. Now, it's a good thing you brought this up. So source maps are usually very tricky beasts. And the reason for that is they can match up line numbers, but they cannot match up structurally what the code looks like. They cannot match up variable names and so on. So, but here, we actually get the right set of variables. I mean, this is not a good example, but you can see that you have door, material, assert before each. All the basic ones that were imported are here the way you would expect them to. The reason for this is because we take great care that the stuff that's between your double curlies, so the stuff that goes from over here to over here, we do very little transformation to that particular piece of code. All of the transformations we do are the stuff that's around it. So things like annotation, things like class becoming into the constructor, but the stuff that inside of the constructor stays the same. And as a result, this works actually pretty well with the source maps because the only difference is the line numbers. We're not introducing new stack frames into your exceptions. We are not introducing new variables. We're not renaming the variables. We're not moving the variables around. And so all of these things just match. Now, having said that, source maps are not perfect. And there's always going to be some cases where it's not exactly perfect. But if you look at the transpiled code, which you see over here, again, you will see that the code you rewrite over here is very recognizable, right? This piece of code is essentially what we have written. And so while we generate stuff around it, we take great care to make sure that the actual code that executes is what you have written for all the benefits. Great question. Thank you for queuing that up.
I was wondering if you have any tips for a migration path from one point X, if there's any best practices we could do now.
So what are the best practices for migration? It's an excellent question. Our current philosophy is let's get 2.0 built with all the most wonderful things we can imagine, and then sit down and figure out what the migration steps would be. We expect that we should be able to build a migration story mainly because most of the top-level concepts are same, like directives, and the syntax is different, registration might be different, linking functions without the constructor, and so on. But because all the pieces are essentially there, there should be a migration story that we should be able to build afterwards.
Do you have plans to support current version of Angular? Number 1, 1.4 maybe.
Version of AdWord?
Angular, yeah.
Angular, yes, Angular, yes.
So you switched to the Angular 4 number 2, but what about current version?
So the question is, how long will we support Angular 1X? I don't remember what official stance is, but I believe there's a blog post about this. My primary focus is on 2.0, so I'm not an expert at this. I think Igor could better comment on this. But there is an official stance, and I believe there's a blog post about this, talking about it. And the other thing is, we have a lot of internal projects that use 1.x, and they're probably not going to be migrating to 2.x. So there will be support. I just don't know what the specifics are. Do you know the specifics? But we did have a blog post about it, didn't we? I thought there was one. Closer, closer.
I have a couple questions. Is it on? Okay, now? Okay, great. So number one, I see you're integrating with other Google products like Metro, right? You're building like an Angular UI for quick app development. Are you also thinking about integrating with AdSense? I mean, to grow the ecosystem, obviously you need developers to be able to make money off their Angular apps, and AdSense doesn't work well with Angular Router. You have to refresh the browser to count as a page view. So that's one thing. And second thing, how do you see Angular fitting into the evolution of Android? Is it being developed as kind of like a future replacement as JavaScript advances more, or how does it fit into the evolution of that?
So as far as the router goes, I think Brian, who's working on the next version of Router, which actually I believe is being downported to 1.3, I think he might have some solution on this. I believe the way this works is that AdSense supports special API that when you're a single page app, you can just tell it, I'm navigating to this new page, so pretend this was a page reload. And I believe that thing already exists. How far it's going to be integrated with the router, I'm not exactly sure, but I know that there's third-party plugins that kind of do this particular thing. Yeah, I hope that answers the question.
So I have a question more about under the hood. So I mean, there's been a lot of talk recently about React and the virtual DOM, especially about its performance. And I was wondering whether Angular 2.0 was considering going that route and maybe adding support for server-side rendering of templates.
It's something that comes up quite regularly, and we're debating it. So, but we don't know.
So a couple of questions. One is, as part of Angular 2, are you introducing new test frameworks?
Karma it is so far.
Okay. And then you mentioned about performance as one of the focus for 2. How about additional tools or profiling tools that are planned for Angular 2?
So we had some experience integrating the web tracing framework. I'm not sure if you're familiar with it. You should go check it out. It gives you some wonderful insight into what's happening in your application. So we're going to do a lot more of that in Angular 2.0. Web tracing framework, WTF, and we also, yeah, it's cute, isn't it? You don't know what's going on? Come on, WTF. It's really awesome. It's a really nice piece of technology. I really like it. The other thing is we have internally this thing called benchmark where we run our test suites to make sure that we don't regress, et cetera. And I believe that's open source, right? So you can use that as well. It's kind of complementary to JSPerf. JSPerf is kind of a unit micro benchmark thing. Our bench press is more of an end-to-end kind of a thing. So it's a slightly different use case, but fundamentally it's something similar like JSPerf. All right. When is it going to be ready? When it's going to be ready, when it's going to be ready.
Speakers one more time.
Thanks, guys.